Okay, so I'm glad to see everyone. Hopefully you have a wonderful weekend. It's going to be a little bit cooler this weekend than it has in the weeks past, so I'm excited to, at the very least, get a small tease of what our autumn weather pattern is going to be like. I don't know about you guys, but I'm really tired of the heat. I've been living in, let's just say, Northern California, because I worked in San Francisco, and lived in San Francisco for about 5 years for a period of time. But majority of my, for the past 20 years, it's been in the greater Northern California area. And man, our summers are long, aren't they? They are long and hot. If you don't believe in global warming, just come to Northern California. It didn't used to be like this. 20 years ago, when I first moved here, it was not this hot all the time, right? I remember when I first moved out here, every once in a while during the summer months, and I'm being honest here, every once in a while we'd have a day over 100 degrees, every once in a while. Now, seemingly more often than not, it's over 100 degrees. And I remember vividly in the winter, it rained almost the entire time. I mean, it was like it was like the rainy season. It rained often and hard. Now, how much does it rain during the winter? Not that much, right? In comparison. Say again? Except for the one time. Yeah, we do have our moments for sure, for sure. But anyways, all right. So I'm happy to see that the weather's starting to cool down a little bit as we enter into the month of October. October is on Monday, so that's pretty exciting. Any big plans for Halloween? You guys start thinking about Halloween, right? Even though it's a month out? Yeah? I love Halloween. I got a 3- and a 6-year-old at home, so we are all about Halloween. So much about Halloween. We already have our Halloween costumes, and we've already worn them 3 or 4 times. Right? That's how excited my house is about Halloween. So it's pretty cool. I'm like the one house on the street that like decorates for Halloween. My wife and I, we have spider webs all everywhere. We have like, creepy pumpkins and skeletons. I'm that house on the street. So it's really easy to see. And like no one else seemingly in my neighborhood could care less about Halloween because it's completely empty and then one house is like decked out. Maybe like, oh, Pat's just gonna go crazy. We'll just hang out with him and maybe we'll get some reflected awesomeness from his house. Anyways. I like Halloween. Halloween's a lot of fun. It's the one day of the year that we're just allowed to pretend and be silly and have fun, which I think is unfortunate that we're culturally, especially as adults, we only get one day, right? Which is kind of lame, but.
Zombie baby Jesus.
Yeah, no, I definitely will not be doing that. All right, well, let's jump into our course content today. We're going to start our journey really into the world of scripting today. Okay, so we're going to do some legit programming today. We kind of started it a couple of weeks ago, but I want to kind of revisit some of that UI stuff that we were talking about the last time, and continue our understanding of how this low-level programming can help us as designers craft the experiences that we're trying to design. And I think that's an important distinction and something to remember about this kind of module in GCOM 426, is that I'm trying to give you the basics. I want you guys to understand the basic process and thinking behind creating a whole series of scripts and some code that will help you create your prototypes, okay? I'm not going to make you a programmer in 4 weeks. That's just not going to happen. I'm not going to make you a programmer in 6 weeks, okay? That's not this class. We're going to give you a nice solid introduction to the basics. My goal is that by the end of this semester, you'll be able to look at a script and kind of understand it. It's like when you're learning a language. After a year or so of being immersed in that language, you can like hear it. You may not be able to speak the language. You may not be able to speak, I don't know, Italian, right? But you can hear it and you can kind of understand what they're telling you, right? That's kind of our goal for this class, is just so you guys can understand the basic moving parts and pieces. The only way to learn programming, this is tried and true, is this is something that you have to write. You have to get your hands dirty with it. I'm not going to provide you with any of the scripts that we're going to go over in class, okay? I want you guys to revisit the live streams, watch me go through it, and then, I know this is going to sound silly, especially in the information age, I want you to hand type all this stuff. Because it's only in those moments do you really understand what it is that you're creating and how the impact of what you have written is generating the interaction in the game itself. So there's a tactile experience that you need to have to help you learn this programming infrastructure a little bit more directly. So I'm going to force my hand on this one because it's really the only way to learn. It's like when you're learning how to be a 3D modeler, right? Yeah, you can go and download a mesh, right? But are you really learning how to 3D model in that moment? No. Same thing with the scripting, okay? You can go and copy and paste things, but are you really understanding it? Are you understanding the structure, the thinking, the flow of the data behind the scenes? Probably not, okay? So we're going to start taking baby steps into this system. Let me just launch Unity here, and while this gets going, we're going to start talking about the context of the little game that we're going to be making over the next couple of weeks, because there's going to be a lot of moving parts and pieces, and this is an excellent, excellent place to begin if you're, I don't want to go to the update, thank you. This is an excellent, excellent place to begin if you are, when you're starting off creating the functionality of a game, because we all have wonderful ideas, but we really need to spend some time looking at how all of these structures are going to be created, or what structures need to be created, and how they're going to work together to give you the result that you're after. All right, so whenever I start any project, I always write it down on paper first. This is something that we've done in this class, okay? And I always start with a premise. What is it that we're trying to establish? What is it that we're fundamentally trying to create? And I'm just going to write some of these things down on the board so you guys can see it. So the premise of our little game, let's see, the premise is a simple seek and find, find game that encourages the player to find 5 coins. Find 5 coins. Coin? I can spell. Coins. There we go. So that's the game. That's the game that we're at. It's just a simple seek and find game, okay? Let's add the condition, the win condition. Once the player successfully finds all of the coins, player wins. I'm going to put that in quotes. Wins and advances to the next level. All right, there it is. That's the high-level premise of this game, and I'm just going to, it's way too big. Okay, cool. Simple seek and find game that encourages the players to find 5 coins. Once the player successfully finds all the coins, the player wins and advances to the next level. That's it. That is the big picture idea of what we're trying to create. Okay? From this one statement, these 2 sentences, we've defined what the player is going to be asked to do and how the player is going to win that game, right? We've defined the outcome. And as designers, that's something that we can't look past. What are we trying to march our players to? How are they going to know that they've reached the conclusion of the game, and what system are we using to communicate that outcome? Okay? So this is the premise. Now from this premise, we can start to figure out pretty quickly here what exactly we need to build. Okay? And this takes some time. What to build? Okay, what are we going to build? It's a good question. Okay? This takes some engineering, okay? And I'm just going to write down some bullet points of some ideas that I think that we're going to need to build in order to make this happen. When you go through this process of figuring out what you have to build, don't think about how you're going to do it. That's not this time. We haven't gotten to that yet. I'm not going to spend a lot of my energy figuring out or answering the question of how, because I don't even know what I'm going to build yet, okay? Let's answer the question of what first. What do we need? Okay, so for my little game here, what do we need to build?
Coins.
So we need to have some sort of system for coins, okay? System for coins, okay? What else do we need?
System for player.
Yep. System for player, okay? What else? Say again? Text. Well, I'm going to advance that just a little bit over to the interface. Interface that communicates coins, lives, and game status. Okay? Oh, I forgot. In the premise, I apologize. Players provided 3 opportunities to find all of the coins. So I'm suggesting in that one statement that the player is going to die, okay? So they're only going to get 3 chances, okay? If they walk off the edge of the map, they lose a life. If they're smashed by a falling rock, they lose a life, right? So we're going to, there is a motivation to get through all these challenges, before their lives are eliminated, right? So we also need a system for, you know what? I'm going to put the system for player lives. Okay, so at coins, we got the player lives, an interface that communicates all this stuff. What else are we going to need? Say again?
A level.
A level. We're going to need a level. Okay, absolutely. So we need some sort of environment, right? Forgot something in my office. Let me get it real fast. Keep thinking about what we need to build here. Programs that we're going to have to generate. Oops. Yeah, you could storyboard all this out if you wanted to. We're going to look at how these systems are going to interact with each other here in a minute.
Would inventory be under the system for coins, or would it be?
Yeah, that'd be the coin system. Yeah, and understanding a programmatic understanding of how many coins there are and how many coins you found. Yep, I like that. Okay, we're also going to need a win system. Or let's just do system for win scenario. Oops. Yeah, absolutely. We'll kind of file that under the win system. Yep, I like that. What else? I wrote all this down earlier as I was prepping for class. I want to make sure. Yes. Another thing that I thought might be kind of fun is a system for placing the coins on the level. That might be kind of cool, right? To have our coins randomly appear at different locations. Like every time you restart the game, the coins are in a different location. That might be kind of fun. Kind of changes the challenge a little bit, right? I like that. So it's not always the exact same challenge over and over and over again. That might be kind of fun. Let's see if I got everything that I wrote down earlier. Oh, yeah. And then system for placing the player. So these are the things that we're going to need to build in order for this simple little game to take place. Because in my imagination here, when I'm prototyping in my brain, is a game where the player starts. Okay, he's spawned magically, he or she is spawned magically somewhere within my level, right? He now has to go find all of these coins. There are going to be certain environmental or just certain challenges within the level that are going to stop our player from finding these coins and hopefully influence the number of lives that the player currently has. But if the player is successful navigating in all these challenges, they'll find all the coins. Once they get to 5, ta-da, they win the game. Move on to the next level. Okay? That's the big picture idea here. Now this entire little simple concept is going to allow us to really establish a nice little foundation in programming, because all the functionality that we're going to see here is going to be done through code. Okay, and of course we'll sprinkle in some interesting Unity stuff along the way. I thought it might be cool towards maybe in a couple weeks we'll start talking about the animation engine. Maybe we can start looking at how we can animate the coins. So as they're sitting there inside the level, they're spinning, and then when we collect them, just like Mario Brothers, maybe they get big and like spin up and like smash away. That'd be kind of cool, right? So we'll start adding layers of detail into the system as we get more and more into it. But this is a good perspective to have, because now we have a laundry list of things that we need to create, right? Now we know exactly what we need to build in order for this game to happen, or what we think this game needs to happen. This will more than likely change as we start to go through the physical creation of all of these assets. But let's jump over into Unity and start physically building some of this stuff. We're not going to get to everything today, but we are going to start laying the foundation, especially for the interface. We're going to go back to interface stuff. I know we talked about it a couple weeks ago, but we're going to go back and revisit it since it's been a couple weeks. We're also going to explore how we're going to create things and how we're going to kill things, okay? So this is going to be, kind of our God day. We both give life to cubes and then we destroy cubes, right? Yeah. One thing to keep in mind as we go through this kind of next couple weeks is that you're going to have to apply a lot of these ideas. You're almost never, ever online going to find a hunk of code or a snippet somewhere that completely, does exactly what you want it to do, right? You're going to have to apply some ideas to your code snippets and what have you to make them work inside the context of your own game, right? So these ideas are important. If you come up to me and say, hey, Pat, how do I do X, Y, and Z very specifically? I'm going to go, that's an interesting question. Let's see how we can apply some general concepts to the context of your game, right? So keep that in mind. That's my little disclaimer going forward. It's all about the application of an idea, not the physical. I'm not going to give you a recipe, let's put it that way. Okay, let's create a new game. Come on, Unity. You can do this. There we go. Let's call this test enviro. Put it right on my desktop. Let's create the project. We'll get going. The first thing that I'm going to do in Unity is start laying the foundation for the series of scenes and levels that I want to work with, okay? I've learned from my experience that if we set the foundation pretty early on, at the very least we create a main menu and maybe like level 1, okay? It helps us iterate a whole lot faster, right? So we're going to continue where we left off, talking about interface stuff. And this is something that we should start to apply to all the stuff in our own projects and what have you. Just going to reverse. There we go. I like to have my hierarchy over here, my project panel, like that. Okay, cool. So let's get to work here. What I'm going to do is that I'm definitely going to get out of sample scene. This is a landmine that people step on. Okay, let's give it a good name. File save as. Call this main menu. Shoot, while we're here, let's be really, really good stewards of our scenes. Okay, I want to put main menu in my scenes folder, and then I'm just going to get rid of sample scene. Bye-bye. Yes, I'm sure I want to do it. I understand that it's permanent, but we don't want sample scene anywhere inside of our Unity project directory, right? You know what? It's kind of hard to see the screen. Hey, Jasmine, would you mind hitting the lights, please? Maybe flip down the middle one and turn up the third one. Thank you. Perfect. That's so much better already. All right. So let's start talking and revisiting some of the ideas that we focused on the previous week in the context of our interface. Now, what do we need to create inside of Unity to start creating on-screen buttons and what have you? A canvas, absolutely, a canvas. Now, there's a couple ways that we can do this, okay? Of course, if we go to Game Object, UI, there it is right there. The canvas is just kind of a visual representation of the boundaries of our screen. It's where our interface elements are going to be drawn and exclusively drawn. So we've got to be mindful of its role inside of the system itself. You could individually create a canvas, which is fine, or you can just create, let's do this. I'm just going to create an image. If you create any of these things up in here, bloop, it will automatically create a canvas for you. Okay? There you go. When I zoom out here, you can see our canvas. And there it is, looking pretty great. Now, I created just a simple image, but what I'm going to use is, this image section to populate a button. Now, we went over a couple weeks ago how we can create a button with text. I actually brought a button with me, something that I created over in Photoshop. So let me just import that asset in. Before I go any further, let's create a folder called UI images, and I'm going to import a new asset into that folder. All right, so there it is. Whoops, sorry, I didn't mean to click off it. It's just a silly little button. You can kind of see an idea behind it. I made this over in Photoshop. That's all it looks like. When you're importing images into Unity, you have to do some work in the inspector to ensure that the inspector understands the role and the function of this asset inside the system itself. So the texture type is not going to be default. I want this to be a 2D and a UI tagged element, which is going to give me some extra features in here. One of which that I'm super excited about is it's going to remember the transparency. Now you got to hit the apply button for all that to take place. and things are starting to work. Okay, so there's my image. If I go back over into my hierarchy, this image here, this is the UI element that we created, and one of its properties is a source image. It's currently blank, so it's taking this color field as the input. I want to put my button down in there. Now it's a little squished. I remember that when I created this over in Photoshop, it was just a 300 by 100 pixel button. Yeah, there it is. Now it's starting to look pretty great. However, I certainly don't like its position inside the frame itself, and you can begin to see the relationship between the canvas up here inside of my editor view and my game view down here. Wherever this button resides is where it's going to be placed. Okay? So one fast way to get that button in the center of the screen is just to reset the component. Okay? The little gear icon for all of those components in a game object is going to give you these values. Let's just reset it. And now that button, bloop, it's right in the middle, but it also reset my width. There we go. And now it's in there. It's kind of hard to see. It's actually very hard to see, isn't it? Especially in that environment. So I want to start to reduce the impact of the environment, that gradient in the background, by adding, let's just do it real fast, another image. Okay. This first one, this is the play button. Button play. There it is. So let's add another game object into the scene. And we're going to do another image. Okay. Now this next image, this is going to be the background. Let's name it as such. And we're going to change some of the properties of this object, specifically the size and the color, all things that we need to change. I want this object to be the background. So let's make it much bigger. So it kind of fills my screen. Let's give it a nice color, maybe a mid-gray, somewhere in there. Now, this is a little frustrating because if you look at, oops, I zoomed in the wrong spot. If you look at what's going on, where's my other button, my other image? Seemingly it's gone, right? But it's not. It's being covered up by this object here. Okay, this big gray square. Now we get to change that by changing the layer order of all the UI elements in the hierarchy. If you look very carefully, my play button's on top, my background is second. It's underneath it. Now in the Photoshop world, this would make sense, right? Whatever's on top is whatever's going to occlude whatever's on bottom. But in the Unity UI world, it's actually reversed. Okay, there it is. Okay, what we're creating here is a draw order from bottom to top, just like Modo. Actually works identically to the way Modo operates. Okay, the computer starts at the bottom, draws that, and then it draws that. Okay, so your layer order goes from the bottom to the top. And now, haha, things are working the way we want them to work. If you look downstairs, yep, that's a good place to begin.
Where did you grab the play button UI element?
I created that. I created it over in Photoshop, and it really is just a rounded oval with the word play in there. I didn't do anything too fancy. I did that just to kind of simplify this entire sequence a lot. If you want, I can just give that button to you. That way, you guys have something to play with as well. Here, I'll give you a whole bunch of stuff. You're welcome. I'm a giver. I'm a giver. That's what I do. It's part of my nature. I'll give you all the stuff that I created externally. So you guys are working with literally the exact same things I'm working with. I just gave you a nice little bundle of goodies. Should be on your desktop if it isn't already. I gave you 4 texture files and that exact same play button. So definitely check it out if you want to play along. And I really encourage you to play along. I really do. That's the only way to learn this stuff is to physically import it in, wire it all up together, and as you know, as other people have said, to fail often, right? You learn more from your struggles than you do your successes. So do it. Play along. It's really quite helpful in my opinion. All right, so things are looking pretty great, but we have, some have some things in here that we want to just kind of double check. Okay, see how I'm increasing and decreasing the size of my frame. Now, right now, my play button is doing exactly what I want it to do, and it's staying in the middle. However, let's change this ever so slightly, just so we can understand how it's being linked or locked to that. And actually, if you look carefully here, we have a big problem I've made my viewer size so big that it's actually going past, yeah, check it out. Now we're no longer, the gray background is not scaling, it's not anchored to the frame itself. Let's start there. If I grab my background, there's a couple things that we need to look at, specifically this, and the anchors, okay? This in here allows us to set the anchors, where this object, if you will, is going to be pinned inside of the canvas, okay? Now I want, no matter what the screen resolution of my interface to be, I want these UI elements to remain in the exact same location. So this first one, this is the default. It's pinned to the center. Now my play button is already in the center, yay, but my background is also pinned to the center, but it's not stretching. I want that background elements to stretch, okay? So if we go to the red is its location. So all of these are location, and then the blue ones with the arrows, this is going to stretch and distort your image to ensure that it stays within inside the canvas. So let's just do that, see if that worked. Oops, it's kind of oh, now it's stretching too much. I've broken it. Let's put it back to maybe, let's see, if we stretch it this way, will it stretch? Oh yeah, I think I have a value wrong somewhere. Point being, you have to experiment with this and try to get it where you want it to go. Let's just pin it back here in the center, see what that gives us. Another idea that we can try is perhaps we can pin it to like maybe one of the corners. See if that works. Yep. You know what? My play button, it could just be the location of my button itself. Yeah, it's not docked over there in the center. Point being, and larger point being, you just got to go in and triple check all this stuff, okay? You got to make sure that it's positioned where you want it to be positioned, and then pinned where you want it to be pinned so that it moves with the size of the screen. All right, for today, I'm just going to keep going. That works for me. That's enough. Oops. Okay, I got to fix it. There we go. That seems to be working. I told it to stretch vertically, and that seems to be working. All right. All right.
Could you make it to where it'll fill the whole page, the background, like you want to?
Yeah, mine is right down here.
Yeah.
Yeah. And I just made it really big. Yep. When you get out there in the real world, you'll have defined sizes for your interface. It's a little bit easier, especially if you're making, if you're making a game for like a console. Being able to, you'll understand the screen resolutions that you're going to be working with. It's basically it's going to be smaller than 4K these days, or UHD. If it's on the computer, it's a little bit more of a moving target, but at the very least, there'll be defined sizes that your game will support when it comes to the pixel resolution of the image. So you got to make it big enough and just respond enough to, have these things go where you want them to go. We'll talk more about this pinning as we get into like the life meters and the health bars and all that jazz. So, but let's get our button working, because right now, if we play our game, unsurprisingly, nothing happens. So I want to be able to click on that button. Okay, let's go ahead and start adding some functionality into our button game object. Now, if you remember, this is just an image. It has no kind of understanding of what a button is. In order for us to get that functionality in here, we have to add an additional UI, an additional UI component for this game object. So if I go to Add Component, I'm going to scroll down until I find UI. Here it is. Here's the button option. Now this specific button component allows us to start adding some things in here, like a color, a highlighted color, a pressed color. You can even determine what you want the transition to be. Right now we're going to do color tint. We'll talk about animation later on. It'd be cool like when you hover over your button, maybe it like moves to the left, slides, and then when you mouse over, it slides back. And we'll talk about that stuff in the future when we start exploring the animation engine inside of Unity. But for today, we'll just do a simple color tint. Now, I'm going to keep the normal color as white, okay? Now, one thing to remember is that this is a tint. We are tinting something, okay? So if your root image is black, you're never ever going to be able to tint it white, okay? I always like to have things be kind of a pure white value, because then I can start tinting them if I wanted to, right? So the highlighted color, I don't know, let's make it just a nice shade of orange. And then when we click on it, I like to give a little bit of feedback that something actually has happened. Let's just make it, I don't know, a nicer shade of red. Okay, let's test it. Game's playing. I roll in, I roll out, I click, it goes red for a second. Life is good. Bloop, bloop, bloop. Cool. Okay. Now, if you're not getting the functionality that I was getting, pay really close attention to the bounding box of your button game object. This determines where that rollover state is going to be registered inside the screen. Yeah, go ahead.
I'm having an issue. I think I brought in the picture, but it's not, or the play button, but it's not popping up on my canvas.
Okay. Did you drag it into your canvas?
Yes, I believe.
All right. What computer number are you, Andy?
I am computer 10.
All right. Let's take a look. Excuse me. All right. So, okay. So how do you get your button into your hierarchy? So you got an image in there.
Yeah.
Okay. If you click on image, go ahead and click on it real fast. Ooh. You double clicked on it, which is fine. Click on the actual image game object in your hierarchy, because that's what we want to influence.
Right.
Oh yeah, no, you put the play button image in there. You know what I would do, Andy? I would reset the transforms of this specific game object. So if you go over into your inspector.
My inspector?
Yep, over on your right.
My right.
Yeah, see how it says rect transform? That defines where this button is going to be placed inside your canvas. Yeah, reset that guy. There it is. It probably was just placed off screen somewhere.
Thank you.
You're welcome.
I'm having a similar thing with when I go to apply the play button image.
Mm-hmm.
The thing is looking for a sprite. Instead, he just doesn't see the.
So there's one thing that we didn't do upon import, Taylor. When you import in an image that you want to use as part of a UI system,
Yeah.
go to your project directory and click on it. And in the inspector, we need to change the texture type to sprite, 2D, and UI. Yep. Yeah, they're going a really neat direction when it comes to a lot of their 2D graphics inside of Unity. I believe in the next release, they're even going to support scalable vector graphics, which is kind of nice. So then we don't have to worry about pixels. Everything's going to be, upon import, vector-based, which is pretty neat. I'm excited about that. So definitely check it out. There's some good stuff coming down the pipe when it comes to 2D images inside of Unity. All right, so things are starting to look pretty good. I'm a happy camper here. However, what I need to do is start programming some functionality in the button itself. We play the game, the rollover works the way we want it to work. That's awesome, bloop, bloop, but nothing's actually happening, okay? So before we go any further, we need to continue setting the foundation for our game itself, because when we load a level, when we play something, we need to tell the computer in code which level to load, right? Well, right now, we only have one scene file, one level in our game called main menu. Let's add a second level so that we can program this button to actually do something. All right, so now file, new scene, there we go. Now let's save our current scene, that's important. And let's do file save as to give this new level a really good name. And I'm just going to call it level 1. And that's all I'm going to do for the time being. Let's put it in our scenes folder so everything's nice and organized. So I got main menu and level 1. In addition, in order to really make this work, here's something that I suggest that we do pretty early on. We go into our build settings, because the scenes that are in this area of our build settings are only the only games that our menu system is going to be able to access. Okay, let's do it. Let's add the open scene, level 1. I'm also going to grab main menu and drag it in there. Now, this is really important. See these right here? These index numbers, okay? These are really, really important, okay? Whatever level has an index number of 0 is going to be the first level Unity plays upon launch, right? So right now, level 1 has the index level of 0. How do I change this? How do I get main menu to be 0, to have the index of 0? Yeah, we just got to reorder the list. Kevin had it right just by dragging and dropping it. This goes down, and we're on our way. After that, it really doesn't matter in which order all of these levels kind of show up inside the build settings, but you need to define what the first level is going to be by ensuring it has the 0 index. Okay, that's all we're going to do. Now that we have both our levels inside of our build settings, we can return to main menu and continue our work. Excuse me. Okay. All right. So I'm back in my main menu. I now need to go in and start creating a whole series of scripts that will allow me to call on, to load in that next level. Okay, level 1. So let's create another folder over here. And I'm just going to call this _scripts, so it always shows up right at the top. And in this folder, if it's selected before you create anything, whatever you create is going to be placed in that folder. Let's create our first script of the day. And we'll just call this scene switcher. All right, let's double click on it to load it into Visual Studio. Get to work. Double clicked on it, right? Visual Studio takes forever to launch. Yep, it's just sitting down there and tip-a-tapping away, bounce it, bounce, bounce. Visual Studio is a beast. It's a big app. It's a gigantic app. As a reminder, simply double-clicking on the script inside of the Unity project directory will launch Visual Studio. It's the best way to launch Visual Studio because it's going to load in what's called a solution, which is basically your project directory. It's going to load in all the folders, all the subfolders, and it's going to remember the location of the file that you're currently working on. What it gives us is a really nice kind of organic workflow where we have Visual Studio open. When we make a change, all we need to do is hit Command-S and then return to Unity to see if the current effects of that update. Now it's loading, loading, loading. Like I said, it's a beast. It takes a while for it to initially load the solution, or in this case, create the solution. It doesn't take as long the second or third time, but the first time you do it, it's kind of a pain in the rear. If Microsoft is listening to my live stream, make this go faster.
Well, that's loading up. Can you show me the anchors on the background?
Yeah. Oh. All right. So there's a couple updates. I'm going to just close them. I'm not going to do it now. I was doing the updates earlier today, and I had something incredibly frustrating happen. I went through the updates, and it took like probably 30 minutes to update Visual Studio, right? And at the conclusion of the update, I had a gigantic error popped up. Yeah, and I was like, are you kidding me? And it said, failed to successfully update the app. So I went, all right, whatever. So I hit OK, and then Visual Studio launched. So I don't know what's going on. I think it's a bug. No, mine has the icon, but I had that happen to me at home. Yeah. I think probably going forward, the best way to update Visual Studio is going to be through the Unity Download Assistant. All right, so the question was anchor points, back on the buttons, okay? It's right here in your inspector, Taylor.
Yep.
It's this thing. If you click on it, yep. Shift also sets the pivot points. Alt also sets the positions. This probably was where I was not having mine done correctly. but give it a good look. This is how you make sure that your buttons are staying where they need to stay inside the boundaries of your canvas. All right, let's go back over to Visual Studio and start our job. Because there's a couple things in here that we need to do. I want to change some of my preferences.
So, how did you get to the texts?
Yep.
The code to start up Visual Studios.
I just double-clicked on it.
Double-clicked on.
The actual file name itself. Let me just do this real fast, and I can show you. So back in Unity, I created my C# script.
Oh, right.
Yeah, and then I double-clicked on it, and it launched Visual Studio. So if you're like me and you have a hard time seeing your code, okay, because sometimes it does appear very, very small, you can go in. If you go into the preferences, okay, right there, you can go into the fonts section and change the size of all your fonts. I wouldn't recommend changing the actual font itself. I think having a consistent font face for all of our scripts kind of reinforces visually what it is that we're making. But I would encourage you to change the size, and you do that just by clicking on this part and changing the size. Okay, especially in an environment like this, I think Adrian appreciates that I've made the font a little bit bigger because now he can actually read the text on my screen. So instead of like looking at it with binoculars because the default size is so small. All right. Okay. So let's talk about the structure of our C# scripts. And this is something we went over last time. So give me a quick rundown. What are you guys seeing here? Void start and void update. What are those? Listeners, okay, I like that. Does anyone remember the actual name of what? They're functions. Whoever said that, you're absolutely right. Those are functions. And for me, functioners, I like Kevin's kind of comparison. Okay, it's a listener, it's a bucket, it's a container for instructions. Okay, this is where stuff physically happens inside of our script. If we add something outside of a function, the computer's not going to really evaluate that or know when to evaluate that, and we won't be able to call upon that instruction or that little chunk of data, programmatically easily. Okay, so the functions are where things are going to happen. We have two default functions on every script: the start function and the update function. As Indigo pointed out, the start function is going to be evaluated once we launch the game. So once we hit Command P to start our game, boop, whatever's in the start function in every single script is immediately going to get fired off. The update function happens every single frame of your game. Okay, and this is where we want to put like key presses, actions that we want to have occur every single moment of the game are going to happen in the update function because it's always being evaluated. I think of sometimes these functions like questions, okay? Whatever question we put inside the update function is going to be asked every single moment of the game or while the game's still playing, okay? Now, for our UI stuff, we're going to work outside of these two default functions. We're actually going to work with our own function because we want to call upon a very specific code. All right, so I'm going to get rid of all this stuff. And I want to write my own function. Now, you can literally call this whatever you want. We're going to make this a public function. So a public function is a function that can be externally called upon. We want to use the, let me show you real fast. Over in Unity, we want to use this on-click functionality of our buttons to call upon a very specific line of code in our scripts, right? So that line of code, that command, needs to be available to the entire system. We need to be publicly available. If we don't define it as a publicly available function, it's only going to be accessed by the contents or by the other functions within this script, okay? So within scene switcher, that's the only place that these private functions are going to be heard. So I want my scene switcher to be heard by every, or to be made available to any item inside of my game. And let's just call this something silly. Let's call this Pat's scene switcher, okay? You can name functions whatever it is that you want to name them. I don't care. And Unity does not care what the name of the function is. Some names have values and importance to them, like start, awake, update, late update. But if you're writing your own, they could literally be Pat scene switcher. Okay? Okay. Now, when you're done writing the name of your function, there's some housekeeping in here that we need to do. We always follow the name of a function with an open and closed parenthesis. Then we always, after that, add an open curly brace and a closed curly brace. Okay? And I think it's really important that we start defining the correct syntax in our language here. What you see on lines 8 and 10, these are curly braces, open and close. Okay? Or I'm sorry, curly brackets. These are open and closed curly brackets. Okay? I've been working in something else. Those are braces. Okay? So shift braces, curly brackets. These are, I did it again. Those are braces. Okay? So open and close curly brackets, and now we're ready to start writing the commands that we want to use. Okay? Since we're going to be using, or since we're trying to establish the loading of a different level, we actually need to call upon a new library inside of Unity, and it's the scene management library. So there's one thing that we need to add up here. These are all the different collections and libraries of code, if you will, that we're calling and accessing in this specific little code here. So we're going to be using Unity Engine dot scene management. And I like using Visual Studio's little code snippets. It helps you out. The less we have to type, the better. And it's not cheating. Okay? And then, of course, we end that line with a semicolon. Okay? So using Unity Engine.scene management. Without that little line of code in there, the library that includes the actual command is not going to be loaded once this whole thing is compiled. All right, so now that we've loaded the appropriate library, down here in line 10, let's actually start calling the code and writing the command. So scene manager.load scene. Load scene. Now we got to tell it which scene to load, right? So we have to pass it some information, and that's where our parentheses come into. As a matter of habit, one of the things that I find myself doing often whenever I'm writing code is that I'll write the command. If it requires some sort of data type or something to be passed into it, I'll write the parentheses first and then immediately go and close off the command with a semicolon. Okay? It's really easy to forget that semicolon. So before I go any further, I try to write it. That way I can continue working here, not having to worry about this line being returned. All right, so now inside the parentheses, we have to tell it which scene to load. Now there's a number of ways we can do this, but we're going to use the index number of our build settings, right? For me, since I'm loading level 1, does anyone remember my index number? 0, 1, right? 0 was the main menu, but 0, 1 was level 1. Andy, you had a question?
So how did you get scene manager into your script?
I typed it.
Okay, fair enough.
Yep. Yeah, and I think it brings up a really important point here. Code is really nothing more than text. That's all it is. It's just characters. You can write all of this in TextEdit or Notepad. Okay. So it's just text.
And why are you making it 0, 1 for load scene?
Because this is the index number of level 1 for my game.
Where do you put the index number?
Yeah. Let's go back over into Unity for a second. You can find the index number in your build settings. Okay. Because these are all the levels that are going to be included in my game. Here's the index number, that right there. Whatever level is, it has an index of 0, that's the first level that Unity is going to load when the game's launched. So when you double click on the app icon, boop, it's going to load whatever index or whatever level has an index value of 0. So I'm going to load level 1. Let's go back over into Unity, or excuse me, into Visual Studio, and I'm just going to do a simple file save. I'm not going to close Visual Studio. I see people doing this all the time. They'll write some code, and then they'll close the application. They'll physically quit it. No, leave it open and running in the background as part of our workflow, because we're going to need to come back to this script over and over and over again to make changes. If you're constantly opening, closing, opening, closing, opening, I mean, shoot, you saw how long it took just to open Visual Studio the first time, right? So leave Visual Studio open in the background. It's a pretty light program. It's not taking a tremendous amount of your system resources. I just minimized it by hitting Command H to hide the app. And, oops, it happens so fast. Let's do it, just double check. There we go. So here's the script. Just making sure, yep, all this stuff looks good. I'm happy with it. I haven't got any errors yet inside of Unity, so I'm on my way. However, now we got to start doing some stuff here, okay? Writing the script isn't enough. We actually physically need to attach this script as a game component to an existing game object inside the scene itself. Now, it literally could be any game object in the scene. It doesn't really matter where we put it, but it does need to be an active participant of a hierarchy, right? I think for me, just to make it really, really easy, I'm going to put this script on this game object, on my canvas itself. There we go. Now it's a member of an active game object inside of my level, and I can start accessing that in the button. All right. So if I go over to my button, down here at the bottom, okay, this on-click menu is where the lion's share of the work is going to happen, right? We want to call upon the script that we just wrote when we click on this button, right? We need to access it. And specifically, we need to access the pat scene switcher function, because that contains the line of code, the command that's physically going to launch the game, right? So let's add in an on-click action. Now, the first thing that we have to do, I'll widen this, okay? The first thing that we need to do is load the game object that contains the script, right? Do you remember which game object in my hierarchy contains the script? The canvas. And it really is as simple as dragging and dropping that into the image well. Now that we've loaded the game object, we can see the contents. Check it out, scene switcher. That's my script. That's the physical name of the script that I wrote. And if you look at all the options over here, there it is, pat scene switcher. There's the function that we created. So when we click on this button, we're accessing a script. And specifically, we're going into an individual function within inside that script and executing its contents. Okay? Starting to see the logic flow behind all of this? Yeah? All right, let's go ahead and load in pat scene switcher. That's the function that's responsible for physically switching the levels. And the only way to know if you're sure if it's working is to do what? Let's play the game, right? Let's play it. See if it works. We'll know if we have success pretty early on. So the button still works. Ha-ha! Boom! It worked. Okay? Because now it physically switched the scenes. We also get some visual confirmation inside the Unity editor, because look at the current active hierarchy. It's not main menu anymore. It's level 1. Yeah! Rock and roll, Pat. Say again?
And the thing for scene switch, which it opens up a second drop-down menu.
So on the play button?
Yes.
Okay, so scene switchers, you got to find, you got to load in the game object that has a script.
Yep.
And this right here, I went to scene switcher, and then I found my function, the one that I wrote. So you kind of have to look at it in the list. It's a long laundry list of functions. Okay. Yeah, Vo, what you got?
My scene switcher doesn't have the pat scene switcher.
Okay. What did you call the name of your function in your code? Because pat scene switcher, this is what we're looking for. Whatever the name of the function you wrote is.
If there's not a space between the parenthesis and the name, will that cause a problem?
I don't think so. Okay, let's see what we got. Okay, save your script. Cool. Yeah, that looks to be good. Jump back over into Unity and see. All right, so we have an error. It says unexpected symbol, end of file. Double click on the error. There's something in there that it doesn't like. Ah, we're missing a curly bracket. So after line 11, hit return to give us a line 12. Okay? And we need a closed curly bracket. There we go.
Oh,
Yeah, hit save. So what Vo just ran into was a curly bracket problem. Okay? Remember, curly brackets come in pairs. We open and close each class, each function, basically everything with pairs of curly brackets. Okay? If you look very carefully on public class scene switcher, that's the script itself. This is the overall library that we're using, model behavior. It has an open curly bracket. And then down here, this is its pair, right? This is its closing pair. Vo accidentally deleted his closing pair and the script wasn't working, okay? So we got to kind of manage our curly brackets in here, okay? They come in pairs. If we delete one or the other, it's just physically not going to work. One of the cool things that I like about Visual Studio is that if you click on one, see how I highlighted this one? It automatically highlighted the one down on line 12, which is pretty nice. So it will tell you the connection between the curly brackets visually inside of Visual Studio. Maybe that's why it's called Visual Studio. Yeah, what you got?
I have an error on my script.
Okay. What's the error say?
The error says the associated script cannot be loaded. Please fix any compile errors and assign a valid.
All right. So when you run into an error, go back over into Unity real fast. When you run into an error, go open up your console for me. Because sometimes, yeah, I don't think this is not a show-stopping problem.
Okay.
Yeah, if it, when you have a problem, here let me break this for a second, and I'll just remove that. So when you have a problem with your script, Unity is going to tell you. Okay, yeah. See down at the bottom here, big error. Red is I will not play this game until you fix this problem. Okay. Now here's the best way to manage these errors. Simply double-clicking on it will take you to the line. It actually highlights the line where the error resides. Okay. So now, if you look at the error more directly, not only does it tell you the line, but it actually tells you the character. See, it's line 10, character 22. That's where the error resides. That's where you need to start looking. So for me, just 01, save my script. I go back in. If you look over here, see I get the little loading icon? That was Unity and Visual Studio kind of doing a handshake. They're talking to each other. Errors will pop up or not pop up after it goes to that little processing kind of cycle. And we're good to go. Other problems? Everyone getting this work? Yeah? Okay, great. Let's play it again, see where we are. And then we're going to start building out level 1 and start having some fun. Rock and roll. Aha, wonderful. Command P to stop the game. Let's go over into level 1 now. I'm going to save everything. Save my project. Save my scenes. Let's load in level 1 and start getting to work over here. Now, as I mentioned before, today is all about creating and destroying game objects. So I'm going to create a little scene that we're going to build on over the next couple of weeks. And simply, I think I'm just going to start off with a gigantic singular plane, and then we're going to add some additional game objects that will start fleshing out the functionality of my little level here. So let's just do some work. I'm going to create a 3D plane, reset its components so it's at the origin of the scene. Let's name this game object ground. Ah, awesome. And you know what? I gave you guys some textures. I want to use those textures in here. All right. So let's do this. Let's create another folder. And on all of our desktops, I have these four textures. Just throw them in there. Okay, the wood. This is a normal map, by the way, so we got to make sure that it is a texture type is tagged as normal, and don't forget to hit apply. And now I'm going to use those four textures as the foundation for a material. Let's name this material floor, and I want to start loading in these textures. So this is the metallic, this is the normal, this is the occlusion. It's pretty shiny. I'm going to bring the smoothness down a little bit so it's not as reflective. And then simply, here, this is going to drive me crazy. I'm sorry. I'm a super nerd when it comes to organization. There we go. I want to take this material and drag it onto my floor game object. There we go. That's looking pretty great. Man, the wood planks are gigantic, so I need to make it smaller. With my material selected, the inspector will allow me to change the tiling, and let's just put this at, I don't know, let's put it at 8 by 8. Yeah, now all the wood planks are a little bit smaller. Now I have something to kind of play within. I've learned from kind of doing this for a little bit that when everything's white, it's really difficult to visually separate all this stuff apart from each other. Okay, cool. Let's also, I'm going to load in some standard assets here. Open up my package manager, and I'm going to use let's see. Built-in packages. Is it in here today? It's not in here, but that's okay. Oh wait, I'm looking for the wrong ones. No, it's not in here at all, actually. But that's okay. I can always go to the asset store real fast and download them. Just make sure it's not. Yeah, okay, let's just go to the asset store real quick. Download the package that I'm after. It's called Standard Asset. It comes with a really great, easy first-person controller prefab. There we go. Actually, I forgot. It's right here too. It's under the import. Let's just do characters. There we go. So 2 ways of getting to the exact same thing. Now remember the systems here that we're trying to build. Earlier we were prototyping some ideas, some things that we're going to physically need to build with code to get the functionality of the game that we're after, right? So in every sense, we are building our coin system at the moment, okay? Instead of coins, well maybe we'll just use like cylinders or something, okay? So we need to create a system that creates the coins and places them in very specific areas within inside the scene. But then we also need to create a system that destroys the coin and gives us a point, okay? We'll talk about points maybe next week. Today we're just going to create and destroy because there's a lot that goes into that. So we're kind of walking through the system elements for our game. Looks like Unity is done doing its thing. So let's load in the first-person controller prefab that I like. I'm going to use the rigid body controller. And specifically, what we're going to be accessing today requires a collision system. So we need rigid bodies, because rigid bodies inside of Unity allow us to detect when two things touch each other. Okay? They don't automatically detect that. If a rigid body is in place on both of those game objects, then they'll start detecting it. But we've got to have game object that has rigid bodies. Say again?
I just pulled in the FPS controller one and it has rigid body stuff.
Yeah, good. Good. All right. So here's my level. Things are starting to look pretty good. Let's play it. Whenever I add something in, I just immediately play it. That way I can understand if things are working or not working. Hey, this looks pretty good. We'll get to a point where if we fall off, woo! Next week we'll talk about death zones and how to manage our character falling off. It's a wonderful extension and builds off the foundation that we're talking about today. All right, let's go in and start talking about how we can destroy things. So I need something to destroy. I need a coin. Let's just do it real fast. I'm going to create, oops. Yeah, oh, no, just a stretch. Let's create a game object. And I'm just going to create, a little cylinder will do. And for my little guy, I'm just going to make it smaller. It was a little too small. There we go. There's my coin. Things are good. I'm also going to delete my main camera. All right, so there's my coin. We'll pretend that's my coin for today. Okay, let's give it its own material. We'll call this red metal. Of course, its color is going to be red. We'll make it a little bit more metallic. We'll change the smoothness a little bit so it's shiny, but it's also got a quick fall off. I'm just going to left click and drag that onto my coin. Let's see how that works. Yep, looking good. Looking really good. I like that a lot. We're going to talk more about this, but I'll introduce it later. This is today's little freebie. I've made this object pretty reflective. It's pretty metallic. Okay? However, we're not seeing a reflection of this at all, actually, right? If you look very carefully, is it reflecting the floor?
No.
No, right? How do we do that? Does anyone stumble upon this?
Is there like a world reflector?
There's not. Welcome to real-time rendering. We have to create what's called a reflection probe, okay? And these reflection probes will start to generate reflections inside the scene itself, and it's pretty cool. Let's just do one real fast. I'm not going to go. We're going to have a larger conversation about this because reflection probes are a pretty important part of our rendering engine. It's under the light category, under the game object pull-down menu, reflection probe. And what you're going to get is this gigantic bounding box. Now, this bounding box represents the area in which the reflections are going to be created within, okay? And the area that whose objects are going to be understood by this reflection probe, okay? Let's reset its position. Yeah, you can see the little visualization inside the scene is this little sphere. I'm actually going to move it up so it's in the middle of this guy. Go. Let's play it now. See what we get. Oh, I didn't do one thing. Nothing has changed because I forgot to change a really important setting. Right now, the reflection types are only baked. Okay, I haven't baked any of my light maps. If I change it to real time, okay, now, if we change the refresh mode to every frame, okay, let's play it now, see what we get. We should start seeing some reflections pop in. It may not be shiny enough, but this is how we start to get it going here. Oh, I probably should also. There it is. It was inside. It's inside my guy. Like I said, reflection probes are pretty neat. We'll talk more about them as we go through the semester. This is the start of it. They can be pretty costly. Take a lot of processing power. And I may not have made my material shiny enough. Yeah, yep. So it is working. This is probably a material thing. Make it very reflective.
To add a component to either the geometry or the material to make it use
Now I just don't have it set up correctly at the moment, and it could be everything to do with the flat surfaces on my objects. But we'll talk more about this going forward in the future. It's not super critical for today. But reflection probes, I'm actually going to turn mine off so I don't lose. You can see its effect with it on and off. It's starting to actually cast some good reflections in here. All right, let's get back to work here. So we need to start going in and figuring out how we're going to destroy this object. Now, ideally, what would be cool is if we go in and touch this object. So we go in and touch that coin, poof, it disappears. Okay? For whatever reason, mine wasn't, and I don't care because that's not the focus of it. Yeah. So we'll smash those bugs at a later time. So the idea is that we run up to these coins. In order to get the coins, we touch them, right? For today, we're just going to run into them and we'll destroy them, right? So in the Unity way of thinking, the code command that we're looking for is honestly called destroy, which is pretty cool, right? Anytime we get to destroy something, it's kind of fun. But the most important part of this relationship is that we need to get the colliders, okay? Or excuse me, we need to get the collision system between the game player, me, and this thing over here, the little red coin, working together harmoniously. Okay, so we need to detect a collision. Where this detection happens is something that we need to figure out and prototype. I think probably what would be good is that if we have the coin asking a question. Did something just touch me? Did something just touch me? Did something just touch me? Okay, if something touched me, destroy myself. Okay? Yeah, seriously, right? So let's go in and create a new script that will facilitate all of this. I think I'm just going to lovingly call this script Cube Destroyer. Oops. Cube Destroyer. Okay. Let's double click on it, open it up in Visual Studio, and get to work. Okay. All right. Now I'm going to add another function down here at the bottom. You can keep void, or you can keep start and update in there, or delete them. It doesn't matter. But what we want to access is the on-collision system inside of Unity, right? This is another one of those defined functions that Unity understands, right? So check it out. So we want this to be a public function. So public void makes it a function, and it's on collision. Now, I like this about Visual Studio. It's going to be difficult for me to do, but check it out. I just wrote on CO, and it's giving me a list of all the functions that it recognizes and understands. Okay, and this is a great way to learn the kind of built-in functions that are part of our code library, right? By looking at all of these little snippets coming to the surface, right? And check it out. We have on collision exit. That's cool. It even gives you a little description of what this thing is going to do over here on the right. I like that Visual Studio. That's really neat. Okay, but I think what I want to do is on collision enter. Okay, so the moment that these two colliders touch each other, the moment that they enter into each other, something happens. Okay, so on collision enter. I'm just going to arrow down, hit the return key. It does the hard work for us, which is pretty cool. Now we're going to come back to these things here in a second. This is information that we can pass in the function. We'll come back to that in a minute. I'm just going to delete it. And it also did our curly braces for us too, which I'm very thankful for. Now, one of the cool things about programming is that we have lots of opportunity to test if our little program is working. The hardest thing for us to determine is to understand where things are working or what things are broken. So whenever I'm doing collision, I always try to test my collision with something the simplest object ever. Okay. I just want to see if this whole collision system is working the way I want it to. So an easy way of doing that is to do what's called a debug. Okay, is to write some text into our console. It's a great way to test things quickly. So this is a line of code that I use all the time. Debug.log. Okay, requires a pair of parentheses and of course a semicolon to end out the line. But inside the parentheses, in a set of quotes, we get to write a sentence that's going to show up inside of Unity, right? And I'll just do, you hit the coin, okay? So if my collision system's working, I should see you hit the coin the moment I connected on to something, right? Or the moment my player hit the coin. Let's test it, right? This is an easy way to see if this whole thing is working. I'll save the script, Command S, return over into Unity. It's chugging away. It's thinking about it. Okay, as soon as that little processing bar goes away, you're good to go to start loading this script on some game objects. All right, let's be good stewards. This cylinder is not actually a cylinder. It's actually a coin. And I'm going to put, or it's not cube destroyer. Sorry. This is when I was prepping earlier this morning, I did cubes instead of cylinders, so I apologize. If anyone got confused with you, like, Pat, where did cube come from? Sorry, all my notes say cube destroyer instead of coin destroyer. We can change that if we like. Here, I'm going to change it right now just so everyone's on the same page. Coin destroyer, and I'm going to go back. Oops, I hit scene switcher. And I like making sure that this all matches. Save it. Okay, now we're good to go. All right, so I'm going to put my coin destroyer script on my coin. Remember, this is listening in the world, asking the basic question, did something touch me? Did something collide with me? Did something collide with me? Okay, so let's place it on the coin. It needs to be a member of a game object in order for it to be evaluated, and let's test. Let's test it. Hopefully this won't break. We'll find out here in a minute. Okay. So if this whole thing works, I should see something in my console log. Now it's impossible for me to do this and play the game at the same time, but look right here at the bottom of your application frame. This is the console log. It's a one-line representation of our console. So this is where we should be looking to see if we get that little line of text. Okay? The moment I touch it, bonk, ha-ha, mission accomplished, right? I know the collision system is working because it says you hit the coin. Yeah, rock and roll, I did it. Okay, it works. Now we need to make it work correctly. Okay? So the debug.log is a great way of testing things quickly, just to see if it's working. It doesn't take much energy. Now we're going to replace that line, or we can comment it out. This is another way of working. You see, this is called a comment. Okay? When you have something with 2 forward slashes on the line, it's not going to be evaluated by the compiler. It's basically ignored. It's a way for us to like write notes, if you will, in our code to help us understand what it is that we've written. So you could just comment this out. Doop, doop. See how it all goes gray. Awesome. Or you can just delete it. I'm happy either way. All right. So let's actually do something now. Now, earlier I mentioned that the code that we're using, or the instruction that we're using, is physically called destroy. But we need to tell it what to destroy. We just can't say destroy, although that would be kind of neat, right? Destroy, destroy. In parentheses, we need to tell it specifically what we're going to destroy. Now, when we're talking, so does anyone have an idea of what we're trying to destroy here? Yeah, game object. Okay, we want to destroy itself, which is weird. So we're basically creating a self-destruct button for this little coin. When something collides with it, we want to say self-destruct, destroy itself. Okay, so when it's a small case G like this, okay. Okay, when it's a small case G, what we're saying is destroy me. Okay, when it's an uppercase G, we're basically saying destroy someone else. Okay. Because I could go in and say, if something touches me, destroy the floor, okay? If it was a capital G. When it's a lowercase g, this is me, destroy myself, okay? All right, let's save the script, return back over into Unity, and see if it works. All right, let's play the game. Hopefully it works. Yahtzee, it worked. Woohoo! Now look real carefully. Hopefully it will let me do this. Look over in my hierarchy. What happened to my coin? It's really gone. Like gone, gone, gone. Will never return until we stop the game. So when we destroy something, we physically delete it from the level itself. Okay? So be mindful of that. This can be a problem. okay? Because there's only one way to get this thing back, and it's called instantiation, okay? So the destroy command will physically delete that game object from the environment, but we probably need to have a system that allows us to create something so that we can both create and destroy it in code, you know, kind of at will, if you'd like, all right? So mission accomplished, but this is maybe not the best way of doing it, right? Okay. I tell you what, we've been going for almost 2 hours. Why don't we just take a small little break, and then we'll come back and let's talk about instantiation. Sue, you had a question? Okay, so let's just kind of check in, see where we're at. So when we left for break, this is where we were. Okay, so the idea is that once I start my game, my player, once it loads, there it is, we'll go over, I touch the coin, bloop, and it destroys itself instantly, which is pretty cool. Okay. However, there are a couple other things that we can add into this destroy command that are really important to point out. Okay. So there's two things that we can pass into the parentheses. What's going to be destroyed? And this is pretty cool. How long it's going to take before the object gets destroyed. Okay, so check this out. This is actually pretty neat. So maybe I want to put a timer onto it to allow like an animation clip or some other action within inside of the system to be evaluated before it gets destroyed. So if I put a comma and then an integer, a value of 3, now it's going to wait 3 seconds before this game object's destroyed. Let's save the script, return to Unity, and see what we get. All right, so now we'll play the game. I'm just going to go up, touch my coin, boink, 2, 3, bye-bye. Okay, so that we can put a little timer onto it as well. This is really handy, especially if you have, next week or the week after, I can't remember from my notes, you know, we're going to have a little animation that plays, right? We hit the coin, it's going to spin and then make a sound effect, okay? You know, we want to make sure that this game object isn't destroyed until that entire sequence comes to a conclusion. So being able to destroy things with time is really cool, okay? All right. One other thing in here, we're going to kind of kick it up a notch. If you put this into the context of a much more complicated game, being able to destroy things is a really important part. But oftentimes in larger experiences, there's going to be many things that could have colliders on it, right? If you think about it in your games, you may have a weapon system or like, you know, I don't know, enemy AI cruising around your level. Well, I want the only thing to destroy this coin is the player. I don't want to have the collision with a blade of grass swaying in. No, seriously, I don't want to have that collision to destroy my coin. So I need to start filtering what is able to destroy this coin. And we're going to start introducing this idea of tags. Okay, tags are a great way for us to encode filter actions. Okay, and they're pretty neat. I want to have only the player be able to destroy this coin, okay? So we're going to use this tag system. It's really kind of an elegant way of filtering out commands by a condition, by a tag, okay? So I'm on my rigid body controller, okay? And in the inspector, we have this tag section here. See, it's untagged. Let's just change this tag to player. And if you look at what some of these are, you need to add your own tags, okay? So if you want certain events to be evaluated, you know, when an enemy touches this thing. You'll see this with doors. I remember in the early days of video gaming, before we had this kind of this functionality, the enemies would accidentally open up the doors to the level. I remember playing, I think, the original Doom game, and every once in a while you'd get lucky, and one of the enemies would walk close to a door and it would open it, and then you'd be going on, you know, you can attack them. Or sometimes that worked not in your favor, right? The enemy would open the door and then they would see you and then you're on, right? So we don't want that to happen. We only want the player to drive this event. So I want to tag my first person controller prefab as the player, but now I need to return to my code base and ensure that I'm asking a question. I'm accessing that tag, okay? So this is going to be our first if statement, our first condition, our first question that we ask inside of our code, okay? This is an if statement, and it's a question. It's really simple. So let's define what the question is going to be. If statements are really easy to write, okay? And this is what they look like. Of course, it's going to start with if, and then after if, and I just botched it. There we go. After the word if, we need a series of parentheses. The parentheses is really where the question is going to be asked, okay? If statements are kind of like little mini functions inside the larger context of a function. So if whatever happens in here is met, then do that, okay? And actually, I probably shouldn't say then, because that's actually something different in code. If this is true, destroy the object, okay? I'm going to get rid of the 3 just to make it go a little bit faster, okay? So I try to be disciplined. Since they're little mini functions, they actually require their own series of curly brackets. So we're going to change our code ever so slightly. If, there we go, that makes it a little bit easier to see. If, here's the question, if this statement's true, then do that. Okay, destroy the object. So let's write the question itself. Well, we want to access that tag, right? So part of it is going to be accessing the tag, but we also need to start collecting collision information, okay? And this is where these parentheses at the beginning of the function start to come in, because this is a way for us to collect data and then make that data available to the contents of the function itself, all right? So check it out. I want to collect some collision information, okay? So in writing collision in the parentheses, I'm telling the computer, hey, whatever happens, whatever collides with me, I want you to save that information to a word, a variable, okay? We're saving data, right? We're passing it from one area onto another. I'm just going to name it hit, okay? So we're gathering collision information. So whatever touches this thing, it's going to be registered. It's going to like remember it, okay? And it's going to save all that information into the word hit, okay? So now, if whatever we hit, okay, because now I want to access that little library of collision information, right? If whatever hits me is a game object, it's a game object that has a tag that is equal to, what is it? Remember? What was the tag? Player? Yep. Player. Destroy the game object. Okay? Couple little things here that are really important to point out. If you look carefully here, these periods allow us to get more specific in our logic. Okay? Big chunk of information. We're basically saying grab all the collision information that was saved inside this function. Okay? Grab all of it. If some of that data is a game object, remember, okay? And if any of that game object information was tagged with player, now the conditions of this if statement are true. We're going to do what's in the next following lines. So we're kind of going from really general to very specific, okay?
So it's basically like opening files.
Yeah, that's a good way to think of it. Think of like, whatever collides with this coin, all of that collision information is going to be saved into a folder. The name of that folder is hit, okay? In the question that we ask, open up that folder, okay? If anything inside that folder is a game object, remember it, okay? And if any of those game objects are tagged with player, then this question or this condition is true. Destroy myself. Self-destruct, okay? A couple things to point out. Double equals is really important, okay? Two equal signs. Now we're making a comparison, okay? If it's one equal signs, we're changing a value. It's like we're going from red to blue, okay? In here, we're asking the question, is, this is a double, let's just say in English language, this is, okay? The tag is player, okay? All right, let's test it, see if it works, right? Let's save the script, return to Unity, see what we get, okay? I'm almost done compiling here. Oh, I'm done. Let's play the game. Okay, good luck. Mission accomplished. Let's really test to see if it works by changing the tag of my game of my player controller. Let's change the tag. Let's put it back to, let's put it to finish, just for giggles, okay? Logically, what should happen here? Nothing. The coin should stay in its current state because it's only looking for collision information with the player, with any game object that's tagged as player. And yep, it's not doing it. So my little mechanic works. Okay, I like it. Let's put the first-person controller prefab back. Its tagged back to player. Let's move on. Okay, pretty cool, huh? Yes, sir.
So can you tag different multiple players to one object?
Absolutely, yeah. And you can go. This tag editor is pretty robust. You can have as many tags in your game as you want. Yep. I've seen this be used pretty ingeniously, where it just allows you to get very, very specific as to what's going to happen based off this tag.
So does that mean you have to write a new script for that second player, or?
Not necessarily. You can also do, like, let's say you want player 1 and player 2 to destroy the coin. Okay? You don't have to write another script to facilitate that. You can do this. And copy it. Yeah, like player 2, player 1. We can do and statements, okay? Yeah.
Why does it only work with a rigid body FPS controller and not
Yeah, Taylor and I were exploring that a second ago. We think that there's some magic going on inside of this script that's driving its collision system for this particular game controller. There's something in there, and without going specifically into the script, there's something about this script that's making the magic happen, okay? But this is just actual collision information, but for this game controller. I mean, we could have two boxes touching each other, and the code base would be the same. All right, let's keep going, because what we've done here is we've destroyed some things, but now we need to start creating some things. And this is where it gets a little bit more advanced, okay? Well, there's a couple ideas in here that we need to do. First and foremost, we need to create a system that allows us to create something, but that process of creation requires a couple different things, okay? Now, if you were a machine creating something with code, what are some of the ideas that we probably should be aware of that will drive this action? Think like a machine for a second. Okay, so how many? Okay, I like that. We're just going to do one for the time being. Say again? Where is important, right? In actuality, we need to tell it what to instantiate, what to create, where to create it. And if we'd like, got to have the first two. But the third one's rotation. At what direction inside the scene do we want this object to be created at? Okay? We're going to focus on the first two, the what and the where. Okay? So we need to go in and create the what. Now, I have a coin here, but if you think about it, this coin is actually, it's a game object that I've added some components into, right? I've added a script, okay? I've added a material, a custom material. It's got a custom script. This is more than just kind of a standard asset at the moment. It's a collection of a whole series of components that I now need to call upon through code, okay? Now, in order for us to instantiate, which is a fancy word for create, in order for us to instantiate a game object inside the scene, it needs to exist inside of our project, okay? Right now, this coin, this game object only exists inside this level, right? So I need to create what's called a prefab. And creating prefabs in Unity is really, really easy. I'm basically going to save all the lovely hard work that I've done here inside of my project by left-clicking and dragging it. Okay? That creates a prefab. Okay? If you look at the prefab itself, it still has the same name, still has the script, okay? Still has that lovely red metal material. If you look carefully, it's got a blue cube icon next to it. This signifies a prefab, okay? It's now an asset that I can call upon over and over and over again through code and physically place it inside of my scene itself. I can actually delete this thing, okay? But not to worry, because I can always just add it back in by left-clicking and dragging it, okay? So now that we have the coin saved as a prefab, I can start calling upon it and creating it inside the scene itself, okay? So let's start writing the code here that will allow us to do this. And keep with my pattern here. This is the coin creator. Let's double-click on it, open it up, and get to work, okay? So there's a couple things in here that we need to do, okay? First and foremost, we need to load the prefab. We need to tell the computer, hey, which prefab do you want to create here, okay? And we do that outside of our functions, just to make it a little bit easier. I want to see if this is a preference, because I really hate all of these comments in here. It's just visual noise that's not necessary. I want to see if I can change that. All right. So outside the structure of our two functions, I'm going to create a variable. Now, what is a variable? If you go back to algebra class, what's a variable? Yep, often it's denoted by X or some sort of letter. What's its role in the grand scheme of things in math? Holding a value, right? And a value that at times can be interchangeable, right? Yeah, that's exactly what we're doing here. So we need to tell the computer which specific game object to hold in this variable, right? And then we're going to call upon that variable in code. So this is how we do it. We're going to make it a public variable. Oops. Public, okay? And in C#, we got to data type our variables first. If you're coming from another language, you usually do it second. But in C#, this is going to be a game object, okay? And then we got to give this game object a name. I think I'm just going to call this coin, prefab. Semicolon to end out the line. So we've created a public variable whose name is coin prefab, and we've data typed it to a game object. So we're telling the computer, hey, you're going to be loading in a game object here. You're not going to be loading in like a force or a key press or a color. You're going to be loading in a prefab, an actual game object that exists inside of my hierarchy. Let me show you what this produces. I'm going to save this real fast and jump back over into Unity. I don't get any compiler errors. Yay. Okay. Here's my coin creator script. Like all scripts, it's got to live on something in my game, right? It's got to live on a game object. So I'm going to create an empty game object. This is an old school habit that I've gotten into. I'm going to call this script warehouse. Okay. Some people call it global vars, but this is just going to be an empty game object whose sole function is just to have scripts attached to it. Okay. And now I'm going to attach my coin creator script to my script warehouse game object. Now check it out. In the inspector, coin prefab. So when we create a public variable in code, that now gets exposed in the inspector itself, which is pretty rad, right? Because now we can just drag and drop my coin prefab into that area right there, and that's the prefab that's going to get created upon launch. Okay? So we don't necessarily have to hard code in all of this information. We can create these general data, these general buckets, okay, that David was kind of pointing out, and then we can use the inspector to load all of those values in. So let's do it. Let's put our coin prefab in there.
Sorry, how did you build the prefab?
So I just dragged the asset from my hierarchy over into my project tab.
Oh, wow, okay.
Yeah, it really is that easy, which is kind of nice. Okay. So let me put my coin prefab in my variable slot that I made. So I've exposed that variable in the inspector. Let's return to Visual Studio and continue the rest of our work. Okay. So I've created a variable. I'm actually going to, I'm going to copy that value so I can use it later. And it's absolutely encouraged to copy and paste things because, even though we're all excellent typists here, we make mistakes. I do it all the time. So copy and paste, it really helps. Okay. Okay, so on the start function, let's get down to it, right? Okay, so the command is going to be instantiate. And like I mentioned earlier, in parentheses, semicolon at the end, we have to tell it what to instantiate, which is going to be the coin prefab. I can't talk. And now we have to tell it what. And I love this about Visual Studio. It actually gives you some really great information as to what it's expecting. See, it says object.instantiate. Look, it's looking for an object, right? It's looking for something to load. And then a transform, so a location, okay? So where do we want this thing to go, okay? Well, simply enough, maybe just at the origin of our scene. Okay, we can, oops, sorry. So we need to have some sort of location. Let's do transform dot position. So now it's just going to be wherever this empty game object exists, right? Remember that this script is living on a game object. It's an empty game object, but it still has a transform component associated with it, right? So it still has a location, and actually, if you look carefully, here's the location. Okay. Oops. And I goofed. Transform or translate? I think I maybe translate. So translate. Yeah. Also might have my spelling wrong. Oops. Let's see if that works. We're actually going to skip this entire step because it's kind of silly. So the problem that we're running into here, and I'm having a brain fart at the end of the day, we have to define a specific location, but we don't want we actually want to have some other location in here, right? Because we don't want it to be at the location of my script warehouse, like ever, right? The script warehouse is just kind of a throwaway game object that's just a repository for all this code, okay? We don't want it to be transformed or placed at the location of right there, okay? I don't want it to be placed there. I want to go in and be able to define exactly where this coin is going to go, okay? So here's maybe a better way of getting to it. What if we create some spawn points, some locators whose sole function is to create the location of our little coin. So let's do that. That's probably a better way of working because then we get to define it, and then we actually get to choose in the future when we start talking about arrays, we'll have the computer choose a location for us automatically, okay, randomly, which is pretty neat, right? Okay. So here's what we're going to do. I'm going to create another empty game object, but I'm going to call this guy coin spawn. Okay? You can imagine what's going to happen here. This is going to be the location where this coin is going to be selected, and arbitrarily, I'll just put it way over here. And kind of towards the edge of the map. That way, we'll see a nice test if it works. Okay? Now, let's go back over into Visual Studio. Okay? And let's unhook all this, because this is garbage. We don't need that. But we're going to need to find it here in a second. Okay. So now, we need to find the game object called coin respawn. Okay? So we're going to make another variable. Now, this one's going to be a private variable. Okay? So it's only going to be available. The location of this one thing is only going to be available inside of this script. So it's also going to be a game object. And this, we'll just call this one respawn location. Okay? So this is just a word, but it's really going to be a game object here in a second. Bless you. So when we start working with these functions, you're going to see that there are really some of these defined functions are times within inside of our game. When we start the game, okay, that's when we hit Command P to play the game, okay? But there's actually a function that fires off before that, okay? It's called function awake. It's kind of when the system kind of hums to life, okay? Everything is awoken first, and then the game starts, right? It allows us to do things before the action of the simulation occurs. So we're going to call upon that function. I'm also going to make this private. I don't think we have to make this private, but my notes are saying otherwise. I'm smart enough to not go off my notes. I used to do that all the time. Like, I don't think we needed to do private, and then I take it out, and it would break, and I go, well, I guess maybe I did need to do it private. So this is going to be a week. Unity's or Visual Studio is so smart, it automatically adds the parentheses in the curly brackets. Okay, so before we start the game, okay, before we start hitting the buttons to control our character, we need to grab some stuff. Okay, I'm going to copy my respawn location variable, and I'm going to set it. Okay, I'm going to say, hey, this container is actually going to be a game object.
Wasn't it two equal sign?
No, that's when we're making a comparison. Okay, this is like we're actually changing the value. We're setting the value. Okay, another way of thinking it in terms of English language: 1 equal sign is set, 2 equal sign is.
So this is a definition.
Kinda, yeah, I think that works. So we're going to set this variable to a game object. Game object dot find. So I'm asking it to go out and search and find something for me right now. Game object dot find inside the parentheses and inside quotes. Now we have to be very specific. We have to load in the name of the game object that we want it to find. And in my case, it's called coin spawn. And I'm just going to copy and paste that value so I don't mess it up. So if you look at what we're doing here, okay, we're creating a variable. We're loading that variable with some game object information. Specifically, we're going out into our game and we're finding a game object called coin spawn. Okay, that's all we've done here. We just found some data and we've assigned that data to that fancy word. Okay. Well, now that we have a location, we can access that fancy word. I'm going to copy it. And down here, inside of my instantiation command, I'm going to say, hey, take the respawn location.transform. Let's save it. So if you look at the logic here, okay, we have a variable called respawn location. It's a game object, okay, or we're data typing it to a game object, okay. We're saying that the only information that can be loaded into this variable is a game object. Okay? This will change as we get into more variables. Okay? Other variable data types. Has anyone kind of experienced this before? What are some of the other variable data types that we can use? Numbers, forces, things like that. We can actually have data types just be words. We can data type things to colors if we want. That way, color information will be the only thing that's allowed to go in this small little container. Okay, so and then when before the player starts hitting buttons, the computer is going to find a game object called coin spawn, and it's going to load that game object's information, so it's transform information into this word. Okay, and then when at the very beginning of the game, we're going to instantiate, we're going to create the coin prefab, and we're going to place that coin prefab at the location of our game object. Makes sense? Logically, does that make sense? Okay, let's see if it works. Let's save the game, go back over into Unity. It's likely to break, because that's always the way it seems to work. It didn't break. Let's see if play it, and it worked. Okay, stop the game, Command P. Now what's cool about this, okay, let's play it again. Mission accomplished. The coin spawns right where that game object's location is. So what's cool about this is now we haven't hard-coded in the location of the respawn or for the instantiation of my coin, right? We're not actually feeding in specific numbers. We're feeding in a game object's transformation channels, okay, which allows us to iterate. Maybe we don't like that location. Maybe our playtesters say, yeah, it's just in the wrong spot. Well, I can just change the location of that one game object, and now my coin's going to instantiate over there. Okay? Yes, ma'am? Yes. Yep. And we're going to talk about multiple objects. I don't want to fry anyone out today, but we're going to get to multiple objects, because ideally, Same idea. Yeah, same idea. Yep. Yeah, depending on where you want things to be generated, you may have a whole series of individual scripts. We're going to talk about creating arrays, okay, which is kind of like a whole bunch, like it's understanding a whole list of things. And then we're going to ask the computer to instantiate at one of those points randomly for us. It's randomly going to pick an array number and instantiate at that object's location. This is how we add randomness into a game, right? You know, very rarely do we ask the computer programmers to define randomness, okay? I played a lot of Halo 3, a lot of Halo, more than I probably should have in my day, right? And in the multiplayer, as they do today, you randomly respawn at locations, right? But is it really random? No, it's not really random. They're predefined points, and then you're randomly spawned at one of those predefined points. We're, in essence, doing the exact same thing here. Gives it a little bit of variety. Starts adding a little sizzle to it, as I say. Pretty cool, huh? Pretty cool? Yes, sir.
So can you, so if you were to like randomly place the coins on the map, can you make it so that it's not close to the player when they spawn? Is that like?
Yeah, as long as those, there's a couple ways you can do it, right? If you wanted to ensure that a coin is always a certain distance from the player, you have to figure out a measuring system, okay? But you could also just kind of do it by eye, saying if this is where the player is going to be spawned over here, let's just make sure I don't have any coin spawn points within a certain kind of run distance from there. So, yeah, go ahead.
I'm getting a no reference accepted.
Okay. What computer number are you? 18. Let's check it out, see what we got. Or not. Okay, so it says object reference not set to an instance of an object. Okay, double click on that. It's going to take you to the script that has the problem. Okay, so here we go. So it says instantiate coin prefab respawn location.transform. Oh, go over into Unity again. Let's make sure, where's that script warehouse? The thing that's holding all the scripts? Yeah, script pit, it's got the coin in there. Where's the game object that defines where your coin's gonna be spawned?
The actual object itself.
Yeah, the actual game object. And that I'm looking at your hierarchy, and I think that may be what's missing here. Yeah, that's exactly what's missing here. Because if you look at mine, Taylor, what I have, why this works, we're using it empty. And I named mine coin spawn, so this is the location where the coin's going to be spawned.
That's it.
Yeah. And if you look at the code, we're actually finding that game object right there.
Okay, I was mistaken with the way that was being done. I thought that was looking for the object, not the, okay.
Yep. Other questions on how all this works? Cool. Cool. So if you look at the ideas that we've kind of accomplished and tackled today, we've talked about destroying things. We've talked about instantiation, creating things. We've explored how we can access other game objects with the simple gameObject.find command. We're saving some information in some unique variables, and we've written a couple of our own functions. Okay. Welcome to computer programming. You guys having fun? This is when your games start to come to life a little bit. And every week, we're going to start taking another step forward into this world. Next week, we're going to build off of these ideas and start exploring how we can get more done on our checklist. Okay? Because, hey, look at this. Look what we've done. We've basically created our coin system today. We can just kind of check that off of the list, right? We've created a system that allows us to create the coins, destroy the coins. Now we have a couple things in here that we need to do, right? System for placing the coins, we got that, right? Yeah, now next week we're going to start talking about how we can add points, right? So when we touch the coin, we get a point. And how that point then can be communicated back onto an interface that's dynamically updating. Cool, huh? Pretty neat. I like it. I think it's kind of fun. Pretty rad. These are all ideas that you should be looking to infuse in the prototype that you're creating. Because every single one of you guys are going to have a whole series of challenges and a win scenario. I really, really hope that you're starting to prototype maybe something that looks like this, okay? An idea of the systems that you're going to have to create in order for your gamer to understand the experience that you've crafted. Making sense? All right. So here's what I want you to do. Everyone pull up your prototype. Pull it up, and let's take a look at them real fast. I want to stop the live stream here because the rest is just going to be lab work. Yes, ma'am.